Hey everyone. So you're curious about AI, right? Specifically, how to make AI better at those super complex tasks, the kind that still really make computers sweat.
Yeah, absolutely.
Well, this new research paper, fresh off the presses on arcv.org October 2nd to be exact, really caught my eye.
Oh, interesting.
It might just hold the key to unlocking a whole new level of AI intelligence.
Okay, I'm intrigued. What's the paper about?
So imagine this an AI that's not just playing a game, but planning out its moves like a grandmaster, thinking many steps ahead.
Right. That kind of strategic thinking is still a big challenge for AI.
Exactly. Or picture an AI navigating a website, not just clicking randomly, but actually understanding what it's looking for and figuring out the best way to get there.
Yeah, that kind of complex decision making, especially when there are tons of choices, is something we humans take for granted. But it's really hard for AI to get right.
And that's exactly what this research tackles head on.
Okay, so how do they do it? What's the secret sauce?
Well, they call it reflective Monte Carlo research, or R-MCTS for short.
R-MCTS. Right.
Gee, I know, right? Rolls right off the tongue. But in all seriousness, it's a pretty fascinating approach. What if we could give an AI the ability to not just try different options, but actually learn from its mistakes as it goes?
So instead of blindly searching for the right answer, it's like the AI is becoming more strategic, more thoughtful about its choices.
Exactly.
Okay, I'm hooked. Tell me more about how this RMCTS thing actually works.
So imagine you're trying to find your way through a really, really confusing maze.
Okay, I'm picturing it.
Most AI approaches would be like you stumbling around blindly, bumping into walls, hoping to eventually stumble upon the exit.
Yeah, I've seen AI play those maze games. It can be painful to watch.
Right. But with RMCTS, it's like giving the AI a map of the maze A&ED, the ability to learn from every wrong turn it takes.
Oh, so it's like it's building up its knowledge of the maze as it goes,
Yeah.
becoming more and more efficient at finding its way.
Precisely. And it does this through two main mechanisms. First, there's what they call contrastive reflection. Essentially, the AI compares its successful attempts to its unsuccessful ones, figuring out what worked and what didn't. It's like it's analyzing its own gameplay.
So it's doing its own post-game analysis, just like a human player would.
Exactly. And that leads us to the second key mechanism, multi-agent debate.
Multi-agent debate. Okay, now you're just messing with me, all right.
I know, it sounds a little strange, but picture this. The AI having a brainstorming session with itself.
Wait, hold on. The AI is debating with itself.
In a way, yes. Imagine multiple versions of the AI, each proposing a different move, and they're essentially having this computational argument to decide which one is best.
Wow, so it's like the AI is considering different perspectives, different approaches before making a decision.
That's the idea. And this process of internal debate, it actually leads to more robust decision-making because the AI is less likely to get stuck in a single line of thinking.
That's fascinating. It's almost like we humans do when we're trying to solve a tricky problem. We bounce ideas off others to get different points of view.
Exactly. And you know what's even more interesting? They decided to test this out on one of the most powerful AIs out there, GPT-4, or to be more specific, a version called GPT-4.
GPT-4, now we're talking. That thing's been all over the news lately.
Right. It's capable of some pretty amazing stuff.
For sure. But even GPT-4, as advanced as it is, can still struggle with these really complex multi-step decisions.
That's where RMCTS comes in. It's like it gives GPT-4 this extra boost, this thought enhancer, if you will.
Okay, I like that. So RMCTS is like supercharging GPT-4's ability to plan and strategize.
Exactly. To put it to the test, they put it through its paces in this simulated website environment called VisualWebArena.
VisualWebArena, what is that? Some kind of digital gladiatorial arena for AI?
Kind of. It's basically a testing ground where they can give the AI different tasks to complete on a website.
I see. So like booking a flight, finding a restaurant, things
Yeah.
like that.
Exactly. Stuff that requires multiple steps and decisions. And get this, they saw some pretty impressive results. We're talking improvements, get this, from 6% to 30%.
Well, hold on. 6 to 30. That's a huge difference.
It really is, especially in the world of AI. We're not talking about, tiny little baby steps forward. Those are some serious leaps and bounds.
For sure. That's a big deal.
Yeah.
So how much better is it at actually doing stuff in this visual, whatever it's called?
VisualWebArena.
Yeah, that thing.
So, way better. But get this. Okay, this is what really blew my mind about this whole thing. They take it a step further, right?
Okay.
They actually use the AI's own thought process.
You mean like during the R-MCTS?
Exactly. That whole internal debate thing we were talking about, they
Hmm.
use that to actually train GPT-4 even more.
Wait, what? So they're, like, using the AI to train itself?
Pretty much.
Oh.
And they did this without using any extra data that was labeled by humans.
Okay, now that's just next level.
Right.
So instead of needing these massive data sets,
Mm.
the kind that humans have to painstakingly go through and label and categorize,
Yeah.
the AI is just, like, creating its own learning material
It's wild.
from its own experiences. That's
Yeah.
learning by doing, but, like, on steroids or something.
Totally. It's like bootstrapping itself to a whole new level.
Yeah.
So it begs the question, right? How did this self-trained GPT-4 stack up against the OG system, the R-MCTS?
Head to head. Let's hear it.
Okay, so get the fine-tuned GPT-4, the one that basically taught itself using its own internal reflections.
Right.
It achieved almost the same level of performance as the full R-MCTS system.
No way. So it basically, like, reverse engineered the secret sauce just by thinking about it.
It's incredible.
That is wild. That's like some real sci-fi stuff happening right there.
I know, right? And here's the thing, it gets even better. Because remember how we were talking about how this has to work in the real world too?
Yeah, for sure.
So check this out. The fine-tuned GPT-4, it actually used 4 times less computing power than the original R-MCTS to get those results.
Wait, hold on. 4 times less.
4 times.
So it's not just smarter, it's way more efficient too.
You got it. Smarter and more efficient.
Okay, now that's what I'm talking about. That's a win-win in anyone's
Yeah.
book. But, okay, let's bring it back down to earth for a second.
Yeah.
This all sounds absolutely amazing in theory, in the lab, all that. But why should, like, the average person listening to this even care?
That's the million-dollar question, right? I mean, this isn't just about, like, AI getting better at playing chess or solving Sudoku puzzles. This has some major implications for, well, pretty much any task out there that requires complex planning and decision-making.
Okay, yeah, I see what you're saying. Like, what kind of real-world stuff are we talking about here?
So imagine this AI that can actually automate those super intricate online tasks that we all just absolutely dread doing.
Oof, don't even get me started.
I know, right? Like booking the absolute perfect travel itinerary with flights and hotels and rental cars, or managing your finances across multiple accounts and investments, or even just something as simple as planning a road trip across the country, factoring in traffic, weather, all that stuff, and it just does it all for you.
Okay, now that would be life-changing. Sign me up.
Right. What else?
What else? Ooh, what about robots? Like, this tech could lead to robots that can actually adapt to completely new environments and solve problems on the fly.
Now you're talking. Whether it's like exploring hazardous environments, assisting with complex surgeries, things that are dangerous or difficult for humans, or even just helping out around the house.
Right. We've all seen those robot vacuum cleaners that, like, bump into walls. What if they could actually learn and navigate like a pro?
Exactly. We're talking robots that can actually think for themselves and learn as they go.
I mean, that sounds like something straight out of a sci-fi movie.
I know, right? But it's not that far-fetched anymore.
That's kind of mind-blowing when you really think about it.
It really is. And we haven't even touched on the potential impact this could have on education.
Ooh, yeah. Like, imagine if every student had a personalized AI tutor that could adapt to their strengths and weaknesses in real time.
Right. Giving them customized lessons and challenges that help them learn more effectively.
It's like, finally, education tailored to each individual student. That's amazing.
It really does feel like the possibilities are pretty much endless with this. It really does. I mean, it's like we're just scratching the surface of what AI can be capable of, especially, when you think about its potential to learn and adapt on its own, like without us humans constantly hand-holding.
Totally. And that's what makes this research so compelling, It's not just about making, like, slightly better AI. It's about, like, completely changing how we even think about AI development in the first place.
Right.
It's about moving away from this dependency on, like, massive data sets, which, let's be honest, can be a bit of a bottleneck, and towards these systems that can learn and evolve more independently, more organically almost.
It's like we're teaching AI how to teach itself, which, I mean, that's kind of a wild thought when you actually stop and think about it.
Oh, it's definitely wild. And it brings up some really big questions about, like, the future of all this. Yeah.
For sure. Like, what are the limits here? If AI can get this good at these really complex tasks, essentially by just, reflecting on its own experiences, what's next?
Right. Could it eventually, like, actually surpass human capabilities in certain areas? It's a bit of a thought-provoking question. to say the least.
Totally. I mean, on the one hand, it's exciting,
Right.
all this potential. But then again, it's also kind of, well, I don't know.
A little bit daunting.
Yeah, maybe a little. Like, where do we fit into all of this if AI can do all this amazing stuff on its own?
It's true. It's true. It's a question a lot of researchers are really grappling with right now. But, I mean, the possibilities are just incredible.
They really are. And to think, this all started from a paper about how to get AI to navigate a website a bit better. It's amazing how much potential is packed into these, like, seemingly small advances.
It really is. And it shows how quickly this whole field is moving, right? What seems like mind-blowingly impossible one day can be, like, standard the next.
Totally. Well, there you have it, everyone. We've taken a deep dive into the world of self-learning AI. We explored how giving AI a healthy dose of self-reflection can really supercharge its abilities, and we've even pondered some pretty mind-blowing possibilities of this whole rapidly evolving field.
And as this research shows, AI might just surprise us all by, well, learning to learn all on its own.
It's a fascinating idea to end on, that's for sure. So until next time, keep those minds curious, everyone. We'll be back soon with another deep dive into the world around us.